Right, we're going to have a look at converting from radians to degrees and from degrees to radians. So we'll start there. So you need to remember that 360 degrees is 2 pi radians. All right, remember that relates to the properties of a circle. With a circle with a radius of 1 has a circumference of 2 pi, or a turning angle of 2 pi, which is the same as 360 degrees. So, which means if we divide both sides of the equation by 2, we get 180 degrees is equal to pi. And that's often the basis of the conversions that we use. If we remember that pi radians is equal to 180 degrees, then that helps a lot. Now, if I divide both sides by 180, I get that 1 degree is equal to pi over 180 degrees. And that means that this gives us the number that we multiply by to convert. So to convert from degrees to radians, we multiply by pi over 180. So that's it right there. So from degrees to radians, we multiply by pi over 180. So let's have a look at some examples. So here we are, we're going to convert to radians. 60 degrees therefore, so that's to convert that to radians, we multiply 60 by pi over 180, which we do. So we just write that now as a single fraction, and then we simplify. So 60 over 180 simplifies to 1/3, and therefore we write pi over 3. Now some students are tempted to, on their calculator, to take pi and then divide that by 3, and you'll end up with a decimal answer. When we have simple fractions like this, it's better to leave it in terms of pi. It's more accurate and less of a hassle to write down. Second example, so 100 degrees. So here we take 100 times pi over 180. Do the same thing that we did last time. We just write that as a single fraction. 100 over 180 simplifies to 5/9, and therefore the answer is 5 pi over 9. And again, we're leaving it in terms of pi. So here's an example where we don't. So I've got 13 degrees. So 13 times pi over 180 gives us 13 pi over 180, because 13 over 180 doesn't simplify. This is kind of a messy fraction. You can leave it in terms of pi, but often what we do is, now we do take our calculators, we go 13 times pi divided by 180, and we get this number here, 0.2269. And I've done that to 4 significant figures, so 0.2269 radians. Just note, in all of these examples, I'm not writing any symbol for radians. You can see here that we use a degree symbol, and that's to signify that we've got degrees. But when we're dealing with radians, because radians are true numbers, not arbitrarily decided upon, but based on the nature of the properties of a circle, we don't write radians, or we don't use a symbol or a unit or anything like that. It's just left as a number, and the context will tell us that what we're dealing with is an angle. All right, let's have a look then at going the other way and converting from radians to degrees. So what we do is, well, if we multiply by pi over 180 to convert from degrees to radians, then it must, it seems reasonable that we're going to divide by pi over 180. Now, dividing by a fraction is the same as multiplying by its reciprocal, which is what we've got right here. So therefore, the reciprocal of pi over 180 is 180 over pi, and it's easier to multiply than to divide. So this is what we do. We multiply by 180 over pi. So here's an example. I've got 6 pi over 5 radians. And so we multiply that by 180 over pi. We write that as a single fraction. And of course we see that these pi's cancel out. Then it's just a matter of doing some work on a calculator or otherwise. We've got 6 times 180 divided by 5. and we get an answer of 216 degrees. Now, because it is degrees, we need that degree symbol. Here's an example of where the radian is not in terms of pi. So I've got 1.2 radians, and we just go 1.2 times 180 over pi. There's no pi to cancel out this time, but this is just worked through on a calculator. 1.2 times 180 all over pi, and at 69 degrees to the nearest degree. And often when it comes to degrees, we round to the nearest degree, which I've done in that case.